In this lecture, I will explain how to obtain AC equivalent circuit of BJT amplifier. We need AC equivalent circuit to find out AC response of the BJT amplifier. To find out AC response, we need AC equivalent circuit, and once we have the AC equivalent circuit, we will replace the transistor with its equivalent model. So we need equivalent model of transistor. So these are the two things we need to do in order to find out AC response. I will start with AC equivalent circuit, and after this we will move to the equivalent model of the transistor. So what is AC equivalent circuit? When we analyze the BJT amplifier circuit for the DC signal, the whole circuit will not come in the picture. In the same way, when we analyze the BJT amplifier circuit for the AC signal, the whole circuit will not come in the picture. So we have to simplify this circuit for the AC analysis. There are 3 steps involved in this process. In step number 1, we need to short circuit all the DC sources. We have only one DC source, that is VCC, the biasing potential, and we need to short circuit VCC. So let's do it. I will replace VCC, and in place of VCC we will have ground like this, and we already know the potential of ground is equal to 0 volts. So we have 0 volts at this terminal and 0 volts at this terminal. We are done with step number 1. In step number 2, we need to short all the capacitors. We have 3 capacitors, C1, C2 and C3. C1 and C2 are called as coupling capacitors, and C3 is called as bypass capacitor. Why we are short circuiting the capacitors, I have already explained in the last lecture. The capacitances of the 3 capacitors are very large, and the reactance is equal to 1 by 2 pi Fc. In case of AC signals, the frequency is not equal to 0. The frequency is equal to 50 Hz in India, and the frequency is equal to 60 Hz in America. And if frequency is not equal to 0 and we keep capacitance very large, then the denominator will become very large and Xc is nearly equal to 0. So the reactance offered by the 3 capacitors C1, C2 and C3 is 0 ohms, and in this case we need to replace the capacitors with short circuit. So we have to short circuit the 3 capacitors in step number 2. So I will short circuit C1 like this, then I will short circuit C2 like this, and finally we will short circuit the 3rd capacitor C3. We are done with step number 1 and step number 2. In the last step, we need to redraw the network, removing all the elements which are short circuited in step number 1 and in step number 2. So we need to remove all the elements like resistance Re. The resistance Re is short circuited, so we will remove resistance Re in step number 3. I will quickly redraw this circuit. This is how the circuit will look after step number 3. In step number 3, we have removed all the elements which are short circuited in step number 1 and in step number 2. We can further simplify this circuit. Here potential is equal to 0 volts, and at this point also the potential is equal to 0 volts, and potential of this branch is equal to 0 volts. Potential of this branch is equal to 0 volts because it is connected to the ground. So we can connect this terminal and this terminal to this branch, and once we are done with it, the circuit will look like this. This is resistance R1 and this resistance is resistance RC. Resistance R1 and resistance R2 are connected in parallel, so we can have single resistance, that is the equivalent resistance. I will remove the 2 resistances and we have the equivalent resistance. Let's say it is R equivalent. So R equivalent is equal to R1 parallel R2, which is equal to R1 R2 divided by R1 plus R2. So this is the final AC equivalent circuit of the BJT amplifier. The next thing is the equivalent model of the transistor. The equivalent model of the transistor. We will first try to find out the answer of this question. What is equivalent model? An equivalent model is combination of circuit elements like resistors, capacitors, etc. properly chosen to best represent the actual behavior of the device under a specific operating point. So this is the definition of equivalent model, and we need to find out the equivalent model of the transistor because use of equivalent model is very important. We cannot apply the network theorems directly on the practical device, so we need the equivalent model to use these theorems to find out different network parameters. Like in case of PN junction diode, I explained three equivalent models. The first model was piecewise linear model. The second model was constant voltage drop model, and the last model was ideal model. In the same way, we require equivalent models for the transistor, and in case of transistors, the first equivalent model is hybrid model. After this, we will study RE model. RE model is also called as dynamic emitter resistance model, and the last model is hybrid pi model. In case of diodes, we generally use constant voltage drop model. In case of transistors, we generally use RE model. All the three models are for small signals. In the next lecture, we will study hybrid model, and in the coming presentations, we will complete RE model and hybrid pi model. All the three models are very important in this course, and once you understand how to obtain the equivalent model of the transistor, you can easily perform the AC analysis. So this is all for this lecture. See you in the next one.